Hi everyone, I am Dr. Soumya Asis. Today I am going to discuss a small topic about self-assembly and its applications. As per our S4 Fyugp syllabus, there is a paper named Synthesis of Nanomaterials. In that syllabus, students have to study self-assembly. So as per this syllabus, I prepared this for the S4 Fyugp students. What is self-assembly? It is a spontaneous gathering or collection of entities without external influence. It is observing living and non-living things. Scientists understand the ordered or random assemblies of some smaller entities, blocks, motifs, or units are responsible for the formation of this self-assembly. It is recognized in biology, chemistry, physics, etc. Centuries back, Carnot, Democritus, Descartes discussed about this self-assembly. And Democritus first termed the word atomos, Greek word, that means uncuttable. From that word, the word atom arises, and they says that this is the foundation of matter. But today we know that atoms are again divided into protons, neutrons, and electrons. These electrons and protons are again divided into quarks. All these things. Then what is the scope of self-assembly? It occurs at multiple scales. That is in nano range, that is molecules, nanoparticles, etc. self-assembles. And in macro scales, in biological scales, feathers, wings, etc. we see the self-assembly. And in large scale, astronomical scale, it is seen in the stars, galaxies, and in universe. What are the characteristics of self-assembly? It is spontaneously formed without any external influence, and it is reversible and locally ordered. It is ordered without any external influence, and we can be reversible because it is formed by the weak interactions, but it is thermodynamically stable. It is sensitive. It can revert to disorder, built from weak interactions like pipe interactions, van der Waals, colloidal, capillary, optical, etc. It occurs in living and non-living things. Applications of self-assembly in nanotechnology. We are more focusing on nanotechnology, so I put some applications from nanotechnology. That is Langmuir, blood jet films, that is LB films, micelles, liquid crystals, lithography, self-assembled PAs and anodized alumina templates, photonic bandgap materials, sensors, lasers, Bragg mirrors, solar cells, electroluminescence devices, DNA nanofabrication for nanoelectronics. Then what is the mechanism of self-assembly? It involves weak to strong forces and nanoscopic to gigantic structures in 1, 2, or 3 dimensions. Weak to strong forces interact, and the formation from nanoscopic range to gigantic. In sometimes it's 1 dimension, 2 dimension, 3 dimension. It happens in nanoscopic level. It happens in gigantic level. Everything, and the interacting forces are van der Waals, hydrogen, static charges, magnetic interactions, etc. The driving force to form the self-assembly is to tendency to reach the lowest energy state. That is, the minimum energy state is the stable state. Everything in the universe comes to the lowest energy. It tries to comes to the lowest energy state. Here also self-assembly gives a stable state. So ordered state. We all know that disordered state has the highest energy. Ordered state has the lowest energy. So nature itself trying to set the lowest energy, minimum energy state. That is a stable state. It requires building blocks of same size or shape, that is called a motif. They assemble together to form a self-assembly we see. Atoms and molecules held by stronger forces, but assembly is formed by weaker interactions. We know that sometimes the molecules combine to form self-assemblies. Here, the molecules are formed by the atoms. They are held together by strong interactions. Types of self-assembly. There are 2 types of self-assembly broadly classified, that is static assembly and dynamic assembly. In static assembly, it occurs spontaneously. Every self-assembly is spontaneously stable at minimum energy. That is a static assembly. Example, crystalline structures from melt, LB films, dip and lithography. And in dynamic self-assembly, requires continuous external force from the ambient, that is temperature, pressure, magnetic field, etc. Sometimes at a particular temperature, it will be in the ordered state. The temperature is lowered or higher, the ordered state will be lost. So we provide such ambient temperature, it will be in the ordered state or self-assembled state. And that is here there is a particular energy and it is disordered, its energy will be changing, that is it is increasing. Examples, living plants, animals disintegrate if the input stops. and various types of self-assembly. The static and dynamic self-assemblies are further divided into hierarchical, directed, and co-assembly. In hierarchical self-assembly, interactions at small, medium, long ranges of small building block. Here, small range, medium range, and large ranges of long range of self-assembly happens. Building blocks of self-assembly happens. And directed blocks occupy pre-designed state. In crystals, like the atoms are occupied in a pre-designed site. So that is the directed self-assembly. The motifs are directed towards the pre-designed sites. That is the directed self-assembly. Here, patterned substrate, pores, ordered particles, lithography, etc. Then co-assembly, that is a mixture of two types of molecules, two or more types of blocks fitting together. We know that ABC arrangement we already studied. That is also a co-assembly. Example, DNA templates, S layers. These are the organic, that is seen in our nature. Examples in organic, inorganic assemblies, nanoparticle patterning, etc. Then examples of self-assembly. Self-assembly of nanoparticle using organic molecule. Organic molecule mediated assembly happens via functional grouping. Any organic molecule mediated self-assembly happens by the addition of functional groups. Cadmium sulfide nanoparticles functionalize the carboxyl transferred to aluminum thin films. Here we know that this is the carboxyl group. That is, cadmium sulfide is functionalized with these carboxyl groups. That is transferred to this aluminum oxide. Here is a self-assembly formed. Then another example is dithiols on metal surface adsorb cadmium sulfide nanoparticles to form layers. This is the dithiols that is on the metal surface, and cadmium sulfide is absorbed on the metal surface, that is forming a self-assembly. Here silver particles on oxidized aluminum bound using bifunctional carboxyl thiophenol. That is, carboxyl group binds to the aluminum oxide. Here is the aluminum oxide and this carboxyl group. From the carboxyl thiophenol, the carboxyl groups are bound on the aluminum oxide and the thiol group is attached to the silver nanoparticles. So this is also a self-assembly. Here this is a co-assembly. We can see that different types of molecules. Okay. And then another self-assembly in inorganic material, self-induced quantum dot formation. Quantum dots via epitaxial growth. Example, epitaxial means surface growth. Germanium growing on the surface of silicon or indium arsenide on the surface of gallium arsenide. This is originated due to the strain due to lattice mismatch. Germanium deposited epitaxially up to 3 to 4 monolayers, that is highly 3 to 4 monolayers form epitaxially formed, that is surface is formed, that is it is highly strained, that is strain is increased. Further deposition state can be accommodated. We cannot accommodate the strain. Nano sized islands or quantum dots form spontaneously. We again form here. All of you know that thin films are formed on the surface of substrate. We form this thin film on the substrate. Again, we form different layers. Number of layers increases, then the strain, we cannot accommodate the strain, then the islands are formed on the surface. These islands are formed. This is one island, this is our islands are formed on the surface. Requires substrate temperature greater than 350 degrees Celsius or post-annealing. The size of the islands depends upon the growth temperature as well as the surface plane on which it grows. The surface plane depends on the size of the island depends on the surface plane and the growth temperature. Substrate temperature is greater than 350 degrees Celsius is needed. The temperature is increased, the size of the island will be varying according to the temperature. Then sedimentation driven assembly, self-assembly of preformed particles, materials, silica, titania, polymer beads, latexes, etc. Requirements uniform particle size. These are formed on the surface of a substrate. There is a uniform particle size we get. Example, silicon dioxide particles via sol-gel route. Sol-gel method, all of you know sol-gel method. In sol-gel, this is a solution based method there. Then they are coated on the surface of a substrate. While sol-gel method, we get the homogeneous mixture, and they are coated on the substrate, we get a uniformly sized particles. synthesized in aqueous medium. That is, it is a solution based method. Droplets on glass substrate. We are putting a droplets on glass substrate and it is coated on the surface of the glass plate using a spin coating machine. Then all the solvents are evaporated from the thin film and the particles self-assemble via van der Waals or capillary forces. Any weak interactions, they are self-assembled and formed on the surface a thin layer, resulting in a hexagonal 2D network, minimizing surface energy. Okay, that will be formed. The particles are more or less uniformly coated on the surface of the substrate and the particle size is more or less same. That is happens in inorganic materials. Okay, that is the same as the sol gel spin coating method like this. That is thin film formation. Then applications and biological inspiration. Rich variety of practical examples in nanofabrication, potential in molecular information technology, information storage and processing, compact device fabrication, biological analogy, brain as a self-assembled system, organized wiring to organs, stores, processes and controls information via self-organization. And this is a very short video I prepared for the students, and as per their syllabus, you can elaborate your knowledge by reading so many things related to this. And I take this from the book Sulabha K. Kulkarni. The book name is Nanotechnology Principles and Practices by Sulabha K. Kulkarni. This is a good book and this is the book mentioned in your syllabus. As per syllabus, I follow this book and prepare the contents and present it. Thank you very much.